Last time we showed how J.J. Thomson did the experiment and calculations which undoubtedly revealed the existence of a new particle, negatively charged, that was 2,000 times lighter than the lightest atom, which became to be known as the electron. Let's reflect a bit on the state of human understanding at the time. We had something we thought was indivisible, the atom. Now we found something that is much lighter than the lightest atom. So the question is, what really is the atom made of? For this question, J.J. Thomson thought the atom was a positively charged pudding in which the electrons he had found were floating around. The pudding of matter he postulated had to be positive so that the electrons, which were negative, could be attracted by it in the way we observe in nature that electrons stick to atoms. Is the atom really a uniformly distributed positive charged pudding? The person who next answered this question is actually Thomson's student, called Rutherford, who basically proved his teacher was completely wrong. I am going to show you the experiment in which he discovered the real nature of the atom. But to start, we need to introduce the concept of radiation and alpha particles. Which people of that century were only beginning to understand. Most atoms we encounter in daily life, if you let them sit and don't bother them, will just continue to sit in their current form and nothing will happen. However, a few special atoms are what is called radioactive, which means if you let them sit and don't do anything to them, they will at some point shoot particles at you. Those particles are called radiation, and it is what Rutherford was playing with at the time. He discovered that there were three types of radiation, which he called alpha, beta, and gamma radiation. While it took many years to know what alpha, beta, and gamma actually were, it turns out alpha particles is just a helium atom with no electrons. Beta radiation are just electrons. And gamma is what we know of as light, or photon. It turns out that some of the beta radiation happens to be positive electrons, which I will talk about later. However, for now, let's go back to alpha. Armed with this radiation, Rutherford set up an experiment where alpha particles were shot at a thin gold foil and he measured which way the alpha particles bounce upon reaching the foil. In the next lecture, I will explain how this experiment proved that an atom is made of an extremely tiny and dense positive nucleus, with only empty space between it and the orbiting electrons.